Okay, dokie. So what we're looking at today, we've finished an aspect of content, which was, you know, bring, human impact um, on the planet in terms of getting raw materials, extracting metals, manufacturing. So that part is content, and what I like to do after doing content is go back to the more technical, I say in inverted commas, aspects of chemistry, and we're going to start with naming substances. And I'm going to talk you through how to name compounds. These are only ionic compounds. We've already done um, organic, ionic compounds. Where we looked at methane, ethane, propane, butane, those kind of things. But we're going back to ionic, and I like to revisit the technical aspects because this isn't everyday language. It isn't everyday ideas. So we're going to go back to naming. We're then going to have a look at ionic formulae. We're then going to have a look at balancing equations. And we keep going back over things that are quite challenging over the next few years to make it more fluent. All right. So as always, I like Mr. Hutton's annotated periodic table, and I am going to refer to it. And I do think you should keep a copy of it. The easiest way to get off this Miro board is simply just to click on here and click on download. All right. So in terms of inorganic, the elements here in pink are diatomic, right? Meaning they consist of two atoms. What I mean by that is hydrogen is H2, we naturally find it's H2, nitrogen's N2, oxygen's O2, etc. Their names do not change, all right? And you'll see why in a moment. So O2 is just simply oxygen, even though it's got a 2 there. So this would be oxygen. Now, CuO, one of the things, especially in year 9, is you go, right, I'm going to find CuO on there. You won't find CuO. The symbol of an element starts with its capital letter. So Cu is copper. If you don't know, find it. You get used to looking on the periodic table. There's Cu, capital C, lowercase u, that's copper. So naming this starts with name copper. The metal's name will not change. All right. And the second element in there is oxygen, copper oxygen. Well, it's not oxygen. It is not air, the gas in air that we breathe. It's completely different. It is an ion. So it's not copper oxygen, it is copper oxide. Okay. All right. Now, when we look at something like CuSO4, this, oh no, I'm not going to look at copper. I'm going to look at the bottom first. Again, we've got copper and we've got S. So it's copper, then S, which is sulfur, and it's right here. Now, this would not be copper sulfur, it would be copper sulfide because it has reacted with the copper. These are chemically bonded together and they are ionic bonds. This is copper sulfide. Now, it changes slightly. If you have copper, sulfur, ignore the numbers. We are naming, the numbers aren't relevant. We have copper, sulfur, and oxygen. Without the oxygen, this should be copper sulfide. So if I get rid of the oxygen, this is CuS, exactly like it's copper sulfide. But we've got an oxygen present. So the name changes from copper sulfide to copper sulfate. Now, I've written in two ways. I started chemistry in the 1970s, 1980s, and back then, sulfur was spelt with a PH. So you might see it as sulfide. Generally now we spell it with an F because we like making language easier. Okie dokie. So you've got to name these. Ignore the brackets, ignore the numbers. So for example, I know Fe is iron, nitrogen, not nitrogen. This would be iron nitride if it wasn't for the oxygen, because the oxygen, this is iron nitrate. Anything that starts with a H is an acid. All right. This is sulfuric acid. This is hydrochloric acid. And this is nitric acid. Learn the names, recognize the formulas. Now, if there's an OH, this is an hydroxide. So this is sodium because Na is sodium, and if you're not sure, you always refer back to the periodic table. You don't change the name of the metal ever. So this is sodium, there's OH on the end, this is sodium hydroxide. Now, again, this is for me, ignore the numbers, sodium carbon, not carbide, because you've got oxygen, carbonate. These two are a nightmare. Absolutely horrid. Even year 12 hate this. And it's not because it's a complicated molecule, it may look it, but it's not. This is because of the nomenclature, the naming. Ammonia is a pungent gas. Ammonium, so here you can see the name changes. This is ammonium, got bromine on the end. It's not bromine, it's reacted, so it's ammonium bromide. Okay. Once you've finished this sheet, and I hope you do, don't worry about it, take your time, go on to word equations. So for word equations, you are given a symbolic. Now just remember, you are not concerned by the numbers. This is big M little g. Look on the periodic table, this is magnesium. Plus, now it's O2. This is diatomic, it's just oxygen. And you form magnesium, and a lot of people at this point will say oxygen, but it's not oxygen, it's reacted magnesium oxide. Okay. Those are your tasks. It is not nice, it is not easy, not because it's difficult, it's because it is not something you do every day. Now,